right, welcome to my virtual classroom. Hopefully you guys find this helpful to you. Make sure you're taking notes, and remember that you can always pause, rewind if you don't understand something, or you can pause and try something on your own, and then see how I come about the answer. These things can be helpful for you. So what we're working on this lesson is changing radicals to exponents. And it is 6-4 in your books. So changing radicals to exponents. We've been working with radicals. So if I have something like the square root of 9, we know that the square root of 9 is 3, hopefully. But we can also change this to an exponent. And it kind of has to do with these imaginary numbers that are in math. Not the imaginary numbers, just imaginary numbers that exist. So we know that this is 9 to the first power, right? And this is a square root, so there is an invisible 2 here. I should say invisible numbers, not imaginary numbers. So this is 9 to the first power, and this is a square root, so there's a 2 there. I can rewrite this instead of the square root of 9. It's the same thing as 9 to the 1/2 power. All right? So the denominator in our fraction is the root. And the numerator is the power. So if I put in my calculator 9 to the power of 1/2, I should get 3, because we know the square root of 9 is 3. And we do. Alright, so if we have, say, the third root of, let's say, 7, we could rewrite this as 7, and this 7 has a power of 1, right? So 1 over our root, in this case, is 3. So we can write it as 7 to the 1/3 power. It's the same thing as the third root of 7. We can mix in variables. If I have the fifth root of x to the third power, it's easy to rewrite as x to the power of 3/5. They're equal, identical. You can also go the other way around if you want to. If we have, say, 6 to the power of 2/3, that would be the same thing as the third root of 6 squared. All right? So we're going to work on changing radicals to powers, powers to radicals, and also working through some of the properties of exponents. So we need to review really quickly some of the laws of exponents. The first one, I think everybody remembers pretty well, is the multiplication property. So this says b to the n times b to the m equals b to the n plus m, which is a little complicated, but we know, you guys probably know it better like this. We have x squared times x to the third power. That's 2x's times 3x's, and so we add our exponents and we get x to the 5th. All right? Our second law is the power of a power. I like to call this a superpower. So if we have x to the second power to the third power, that's my superpower, power of a power, we multiply exponents. So that would equal x to the 6th. The reason behind that is because x to the third power, if I wrote that out the long way, it would be x squared times x squared times x squared. So we have 2x's, 4x's, 6x's. All right, the third one, which is power of a product, We'll use x's and y's here. If we have xy to the power of 3, we need to distribute this to everything inside. So x to the third power, y to the third power, z, sorry, not z, just x and y to the third power. If I have some numbers in there as well, say 2x y to the second power, it would be 2 squared, x squared, y squared, and we can simplify that. 2 squared is equal to 4, right? Power of a fraction is the same idea. Power of fraction says that if I have a fraction, say 1/3 to the second power, I have to square everything inside. So I have to square the 1, and I have to square the 3. 1 squared is 1, we know, and 3 squared is 9. So similar to the power of product, we have to distribute that to everything. If we have division, we have to distribute to everything in the numerator and everything in the denominator. To combine those two together, if I had something like xy over 2 to the second power, we would get x to the second power, y to the second power, over 2 to the second power, which is 4. Alright? The last one here is division. Division is like subtraction. If we have x to the fourth power over x to the second power, it means we have 4 x's on top and 2 on bottom, and so we subtract 4 minus 2, and we get x to the second power. So if we're dividing or it's a fraction, we can subtract. Alright, the last one I have then, I'm going to erase this. There we go. The last one I have then is a negative exponent. If I have something to the negative power, let's say 3 to the negative 1 power. This is the one that tricks up most people. It means that I need to take it and move it to the denominator or move it to the numerator. In this case, this 3, I can change into a fraction. It's in the numerator. So I can make it a positive exponent if I move it to the denominator, 1 over 3 to the first power. Let me give another example here. If I have 2/3 to the negative 1 power, it would equal 3 over 2. It's like taking the reciprocal. Even before 3 over 2, 2/3 to the negative 1 power. We can simplify that a little bit to just 2 to the negative 1 over 3 to the negative 1. And then we can change these to positive exponents if we move them from either the denominator or the numerator, the opposite of whatever they're in. So this 3 we can move up top and change to the positive power of 1, and the 2 we can move to the bottom and change to the positive power of 1 as well. Alright, so continuing along, we're going to look at a couple practice problems that have to do with these. So here's an example of something you'll see in class. X to the 2/3 to the power of negative 3. So we know that this x to the 2/3 we could rewrite as a square root if we wanted to. We're not going to in this problem. I think that it'll be easier the way it is. So we know that this is a power of a power, or a superpower. So that means we need to multiply together exponents. So if I multiply these together, I'm going to change this to a fraction. We have x to the 2/3 times negative 3 over 1. When we multiply fractions, we just multiply straight across. So we get x to the negative 6 over 3. Alright, that's almost our answer, but we can simplify a little bit, right? We know that negative 6 over 3 is negative 2. So we can say x to the negative 2 power. Now, an exponent is never simplified if there's a negative in it. So we have to get rid of this negative now. So we can get rid of the negative by taking our x to the negative 2 power and moving it to the denominator. So if I move to the denominator, it'll become a positive 2. That's the way negative exponents work. If we flip them from the numerator to the denominator, or if it was the denominator to the numerator, it'll become positive. So this is going to be our answer. We can't simplify anything any more than that. Alright, let's look at another one. So, here we have negative 8x times the square root of xy to the power of 2/3. Alright, so we have a lot more going on in this problem. So we have a superpower here. We know that we have to distribute this to everything inside here, right? So, we can rewrite this as negative 8 to the 2/3 power times x to the 2/3 power times, I'm going to rewrite this. This would be xy to the power of 1/2. We know that the square root of xy is equal to, this is a square root, so there's a 1 there, and these both have an exponent of 1, so we can write it as just xy to the power of 1/2 from what we learned earlier. And then we're going to multiply that times 2/3. So, simplifying things down, we have negative 8 to the 2/3, which I'm going to rewrite as the third root of negative 8 squared, because I think it'll be simpler to solve that way. Then we have times x to the 2/3 times, if I multiply 1/2 times 2/3, I get 2/6, which is equal to 1/3. So I need to take this 1/3 and distribute it inside here. So we have x to the 1/3, y to the 1/3. Alright, let's see what else we can do here. I know that negative 8 squared is equal to 64. So I can take the third root of 64 times, see we have x to the 2/3 times x to the 1/3. When I multiply variables together, the rules tell me that I need to add exponents. So 2/3 and 1/3 is 3/3. 3/3 is x to the first times y to the 1/3 power. Alright, so the last thing we need to simplify is this third root of 64. So we can do our factor tree and find all the factors and circle the triples. Or we have calculators. So let's see how we can do this in the calculator. If I hit Control, the root button here, I can put, I want the third root of 64. And I get 4. So we have 4x y to the 1/3 power. So here's our answer. We could also write it another way. We could change this y to the 1/3 to a root and write it as 4x to the third root of y. Either of these are acceptable answers. Alright, I have one more problem. But I'm not sure if I'll have time for it.